Hi everyone, it's Mr. Kennard again. This is taking you through Chemical Interactions Investigation 3, Part 2. And this is going to be lesson 1 of 3 that we're going to take you through this investigation. The question that you see on the front page here is, air is matter? Question mark. Well, yeah, we're going to look at and do some experiments and some demonstrations to show you that, yeah, air possibly is matter. And it is a gas that what you saw created from the mystery mixture Mrs. Mott took you through just a little bit ago. We're going to continue that to explain it, to prove it, that air is matter. And then we're going to look at, well, how is it different from other pieces of matter that you might be familiar with? What makes it up? And what can you do to those things as we go along? So stay tuned. We're ready. So let's think back a little bit to the chemical reaction that we had between the sodium bicarbonate and the citric acid. And yes, that was the mixture with water. When we saw that the water added to those two, it bubbled and fizzed. And when that demonstrates a chemical change. And that chemical change, that chemical reaction, there was a gas that was given off. Now, what could that gas be? Well, by looking at the chemical formulas for sodium bicarbonate and for citric acid, lots of possibilities show up. It might be some C's and O's, it might be H2O's, it might be CO2's. And in fact, yes, the gas that is given off is CO2. And CO2, we know, is carbon dioxide, a common gas that we have around us. We breathe it out every day. It's given off when fuels are burned, and plants need it for their photosynthesis. So we're going to investigate what this gas is and how then it is matter. So I kind of gave it away. Where is carbon dioxide found? Well, it is found in the air we breathe. We're breathing in carbon dioxide, believe it or not. It's in the air. We take it in. Our body doesn't use it, but it is part of the air that we breathe. It is part of the air outside that plants can use. It's given off by things that are burning. So lots of things. Where would we find it? Some of you in CO2 cartridges for their paintball guns or other kinds of things. But anytime that it is burning, let me do that. Burning of something. In our case, we give it off because we're burning food, food or fuel. And that is probably the most prime one. So when you burn a campfire or burn trash or burn other kinds of things like that, burning fossil fuels in your automobile, us burning our food in our cells, that produces this gas that is given off CO2. And it is poisonous to us, so we need to get rid of it. And it's also a contributor to greenhouse gases and therefore the climate change that we're seeing. So it's important that we monitor and keep an eye on the carbon dioxide and know how it is being produced. So we're going to look at it from a different standpoint of maybe, well, are all gases like this in terms of their matterness? Most of you probably thought, yeah, what that knowledge, carbon dioxide is in the air that you're breathing, and you breathe it out all the time, and you're also breathing it in. But many of us associate with just oxygen being part of air. Well, air is actually, I'm going to draw this down here, actually a mixture of gases. One of our previous things that we saw was elements in the atmosphere, and most of the air, and what I mean by a mixture is that there's different things that make it up. If I talk about Chex Mix or Trail Mix or even like a Supreme Pizza with all those different parts on it, it's a mixture. You can separate it out. And so what most of our air is nitrogen. We have a lot of oxygen, O2. We have some CO2. And we also have a lot of H2O in there, clouds, water vapor, humidity, those kinds of things. Those are the primary ones. There's lots of other ones in there as well that are given off by factories and emissions from cars and stuff like that. So air is, we want to be able to keep, when we talk about air, it's actually 1, 2, 3, 4, and many more different gases, different substances that make up that air. Well, our key thing with this lesson is how can you demonstrate that gas, in this case, the gases we see, nitrogen, oxygen, is matter? And it goes back to the fundamental question of, well, what is matter? So that becomes our driving question. Is air matter? Well, what is matter? Matter is defined as anything that has mass and then takes up space. Most of us associate things like your chair that you're sitting in, the desk that you're on, the iPad that you're using, your clothes that you're wearing. You as an individual, you have mass and you take up a certain amount of space. That means you can't be in the same place as anyone else, exactly the same place, because they probably have matter too. Well, is air matter? That's something a little bit harder to see because it's not like a liquid or a solid where you could actually see it. In this case, a lot of the air that we deal with is invisible. So how do we know it's there, and how do we know that it is matter or not? Well, we have to prove if it has mass and if it takes up space. And we're going to look at those two questions and try and figure out ways to determine how we can measure the mass and space of air. One of the ways that we can trap air is to put it in like a balloon or a ball of some sort, like a basketball or a football or just any of those kinds of balls. We trap air in there, which allows them to be a little more bouncy and things like that. So is there a way we can find out if air in a ball, or in the ball has mass? Well, in order to find mass, we usually weigh it. Weight is gravity pulling on mass. So even if you go out in outer space, you may not have weight, but you do have mass. So in this case, we're just using the terms because here on Earth, those are kind of interchangeable. Kind of, I say, not to be technical, but yeah, your mass is determined by gravity pulling on it. So in this case, let's see, we're going to take a ball. I've got a little video I'm going to show you here of them taking a deflated ball and then adding some air to it. And before they add air to it, they're going to weigh it. And then after they add air to it, they're also then going to weigh it. And that will determine if the air that they're putting in the ball actually has mass and weighs something different. So here's that video to watch. So as you just came back from the video, you saw it. They took that little rubber ball, kind of a dodgeball ball back in the day. Now they use much softer balls because kids are getting hit with those things in the head and cause concussions or something. But anyway, that one, yeah, like one of those utility balls you'd play foursquare with or something like that. Before you saw, it was flat. They weighed it, and then they pumped up some air, added some air to it, and then weighed it again. So we can answer these questions. Did the mass of the ball system change? Yes, it actually did. You saw that on the scale. It weighed more after the air was added to it. Did we do anything with the rubber in the ball? No, it stayed the same. It was just collapsed before, and we stretched it out with the added air. So no, there's no change in the mass of rubber. We didn't add rubber to the ball. We didn't add anything like that. So, by common sense and deduction, what caused the mass of the ball system to change? Well, the biggest thing is the air that was added. Sorry, that's an A for all my people who want to criticize my A's looking like D's. Air, that's all that was added was air. So the change has to be because of the air that was added. Does air have mass? I'm going to say, heck yeah. Because that thing changed, the amount that it was weighing is only and totally due responsible to the amount of air that went in it. Why do you think so? Well, only air was added. Look at all those D's and A's. Those are all crazy. So yeah, a couple more questions about that. Our next question was, did air take up space in the ball? Well, it was deflated before. There wasn't as much air, and there was a little bit of air in there. They can't completely get all the air out. But yeah, there was some in there, and then they added some more in it. And as a result, the balloon, or the ball in this case, got bigger, it expanded, it stretched out. Did air take up space in the ball? Well, that's what you put in it. It's the same thing if I had a bucket, and I took a bucket, an empty bucket, and I put water in it. It's the same thing. Now water occupies that space that was once empty in that bucket. So the same thing can apply for air. Air occupies space. So yeah, is the bucket empty? No, it's full of air, even when we see it as empty. So if you want to be like a smart aleck to your parents, give me that empty bucket. I don't see an empty bucket. The bucket's full of air. Ha ha ha. That'll get you grounded. Anyway, the point of it is, how else can we prove that air takes up space? One of the things to help us show that air takes up space is a syringe. Many of you have probably used a syringe before or something. It's usually what's given when you get a shot at the doctor's office or something like this. We're going to use some bigger ones, and I'll demonstrate this with a video, but we'll probably also have some syringes here to use in class when you're here as well if you want to. A syringe is a way we're going to use one of them or two syringe systems to be able to trap air inside of it. And once that's trapped in there, then we can manipulate it with the plunger. We can push on that air, we can stretch on it, we can pull it apart, and how that changes the air inside of it. So that's what we're going to look at in this next video that's going to show what happens when you trap air inside a syringe. In this case, we're trying to find out, does it occupy space in that syringe? So as you saw with that video, when they pushed on one of the plungers in that two syringe system, by pushing in on one, it was forcing the air through the tube into the other one and forcing the other plunger to move out and back and forth and back and forth. So what was in there trapped between those two syringes was a quantity, an amount of volume of air. And as a result, you can move it from one to the other and back and forth by manipulating that plunger. Then the second part was when we trap that air in there and try to push the plunger down with just one syringe, notice it springs back when they release it to its normal air pressure. And then when they pulled it out, it sprang back again to its normal air pressure. So that air in there maintains its certain amount, its volume, but you can do two things to it: compress it and expand it. And that's what we're going to focus on coming up next. But first, let's review some of these questions. What did you learn about air using in the two syringe systems? I think that you can move air from one to the other by pushing the plungers. What did you learn about air, number two, using the syringe system that was clamped shut? Was that you could manipulate how much air or how much volume or space that it took up. There was still air in there, it was trapped, it couldn't go anywhere, and you were making the room either smaller or bigger, but it wanted to return to its normal self. Number three, why couldn't the plunger be pushed all the way down? Well, something's in there. Something's is in the way. And that is that amount of air that is stuck in the plunger. A few more questions on the next slide. So can we answer number four? Does air take up space? Yes, it does. We can definitely say that it takes up space. It's in the plunger, or it's in the syringe. We can't push the plunger anymore. What's our evidence? Can't push the plunger any lower. Push, sorry, my stylus, plunger down. Right, it reaches a point where it's not going all the way because there's something in the way. And finally, does air always take up the same amount of space? The same amount of space, can we say that? No, absolutely not. It does not. Because you can move that plunger back and forth, and allow that air to take a bigger space or a smaller space, then that tells us something very unique about air. And we'll talk about that one next. So to wrap up again, go back to our focus questions. We asked the question, is air matter? And I think we can absolutely, unequivocally say yes, because it meets the two definition status. One, does it have mass? Yes, it weighs something. It has weight. And the second one, does it take up space? Yes, because the plunger couldn't be pushed all the way down. There was something in the syringe preventing the plunger from going all the way to the bottom. And that something is air. And the air that makes up it, the nitrogen, the oxygen, the carbon dioxide, again, is that mixture. So we'll continue our focus on air and what makes it up in our next little lesson.